Welcome to this explainer. I am absolutely pumped to jump right into today's topic with you, because we are breaking down a concept that has honestly captivated humanity for well over a century. We're going to look at how time travel isn't just movie magic or science fiction or something out of an old H.G. Wells novel. It's an actual, measurable reality that's deeply grounded in physics. Over the next few minutes, we're going to unpack the hard science behind moving through time. And to do that, we'll be leaning heavily into Einstein's theories of time dilation, using some really simple, relatable, real-world analogies to make sense of the universe's most complex mechanics. So get ready, because what we're about to uncover will completely change how you look at the clock ticking on your wall.
To kick things off, let me tell you a crazy story that actually captured global attention back in March of 2003. So the FBI arrested a 44-year-old man named Andrew Carlson. And why did they arrest him? Well, Carlson had just executed a run in the stock market that basically defied all logic. Starting with a totally meager investment of just $800, Carlson somehow managed to turn it into $350 million in exactly 2 weeks. Naturally, the FBI suspected massive insider trading. I mean, who wouldn't, right? They brought him in, sat him down, and demanded to know his secret.
Well, his answer completely derailed the entire investigation. Carlson casually claimed that his so-called insider knowledge came from the fact that he was actually a time traveler from 250 years in the future. He said he just knew how the stocks were going to perform. The FBI obviously didn't buy a word of it and just assumed he was running some elaborate, complex scam. But then, things got incredibly strange. Investigators found absolutely zero record of Carlson even existing before December 2002, and right before his scheduled bail hearing on April 3rd, he just vanished. He was literally never found again, which leaves us staring at one massive lingering question. Is time travel actually possible?
Okay, let's dive into this by leaving the mystery behind for a second and looking at the actual foundational physics. For a really long time, brilliant minds, like Isaac Newton, believed that time was just an absolute constant. Newton basically thought that regardless of your speed through space or your position in the universe, time just marched forward at the exact same pace for everyone everywhere. But then Albert Einstein came along with his groundbreaking theory of special relativity, and Einstein completely shattered Newton's rigid view. He proved that time isn't constant at all. It's completely relative. It can physically speed up or slow down depending on the physical forces you're experiencing.
To really make sense of this, Einstein asked us to use this exact brilliant analogy. Time is like a river. Just think about water in a river. Sometimes it pools and slows down in certain spots, and then it rushes rapidly through narrow rapids in other spots. Well, the flow of time behaves exactly the same way. The speed at which you travel and the gravitational forces you are subjected to literally dictate how fast the river of time flows for you compared to someone else. This is a real, measurable scientific phenomenon known as time dilation. Just like your pupils dilate, time itself physically stretches and compresses.
And we actually have real-world proof of this phenomenon. It's called kinematic time dilation. In 1971, scientists conducted the famous Hafele-Kading experiment. What they did was take these incredibly precise atomic clocks. They left one sitting still on the ground and put another one on an airplane that flew all the way around the Earth. When the plane finally landed and they compared the clocks side by side, the one on the airplane had actually fallen nanoseconds behind the clock on the ground. Because the plane was traveling at such a high speed, time physically slowed down for it relative to the people standing perfectly still on Earth.
Now, I know what you're thinking. Nanoseconds might not seem like much of a big deal, but scale it up, and the implications are absolutely staggering. Imagine this for a second. You step into a high-tech, light-speed rocket. You travel through space at the speed of light for what feels to you like exactly 10 years. You literally celebrate 10 birthdays on this ship. But because your incredible speed has slowed your personal river of time down to a literal crawl compared to Earth, when you land back home, an astounding 9,000 years will have passed for the rest of humanity. You have effectively traveled 8,990 years into the future.
This means time travelers already walk among us. Seriously. In fact, take Russian astronaut Gennady Padalka. He spent 879 days orbiting in space, traveling at speeds around 28,000 kilometers per hour. Because he spent so much time moving so much faster than everyone down on the ground, time dilation took effect. Today, Padalka is mathematically 0.02 seconds younger than he would have been if he had just stayed on Earth the whole time. He is a literal time traveler into the future. I mean, sure, it's just by a tiny fraction of a second, but the math is absolutely real.
But speed is only half of Einstein's equation. The second method for forward time travel relies on gravity. And here's another really relatable analogy to help visualize this. I want you to imagine the universe as a stretched-out, invisible mesh fabric. This is the fabric of space-time. If you drop heavy balls onto this mesh, representing massive planetary objects, they warp the fabric, right? They create a steep dip or a curve. That curve is gravity. And Einstein proved that the deeper the drop in that mesh, the stronger the gravity becomes, and consequently, time passes much, much slower for anyone caught down in that curve.
Actually, if you've seen the movie Interstellar, you've seen this exact science depicted incredibly accurately. The characters visit a planet near a supermassive black hole, which are the heaviest objects in the universe. Because the black hole creates such a massive plunging drop in that space-time mesh we just talked about, the gravity is immense. In the film, 1 hour on that planet equaled 7 years back on Earth. This is entirely scientifically sound. And to ground this reality even further, in 2019, the Event Horizon Telescope finally captured the first rendered visual image of a real black hole, proving that these immense, time-bending gravity wells truly do exist out there in the dark.
Now, what's really wild is that time dilation is happening right above our heads every single day. Our GPS satellites orbiting the Earth are trapped in this constant, crazy tug-of-war with time. On one hand, they travel at high speeds, which, as we know, means their clocks slow down. But on the other hand, they are further away from Earth's heavy gravity, which means their clocks actually speed up. Because of these competing time dilation effects, scientists have to constantly rectify and correct the clocks on those satellites. If they didn't do this, the time discrepancy between space and Earth would cause all our GPS navigation systems, including the maps right there on your phone, to completely fail.
So we've covered physics, but there is technically a third, biological way to travel to the future, and that's cryosleep. We see this all the time in movies like Passengers, but NASA is actively working on real-life stasis chambers. The general idea is to induce mild hypothermia in astronauts, keeping them in a controlled cold environment that drastically slows down human chemical reactions and aging. It's essentially putting them in long-term hibernation, and we know for a fact it's biologically possible. There was a real-world medical miracle in Japan where an injured man survived entirely without food or water for 24 hours. How? Because his body temperature dropped to just 22 degrees Celsius. His body effectively went into a temporary hibernation mode, slowing his organs and preserving his brain without any damage.
So going to the future is mathematically and even biologically possible. But that brings us to the much, much harder question. Can we realistically travel backward into the past? Now, to be fair, we can currently see the past. When massive telescopes like the James Webb look deep into space, they are capturing light that took millions of years to reach us. We are literally looking at ancient history. But seeing the past is very, very different from actually packing a bag, hopping in a machine, and traveling there.
To illustrate just how practically unlikely backward time travel is, the legendary physicist Stephen Hawking threw a very special party on June 28, 2009. He had the whole shebang, champagne, balloons, an open invitation. But here's the catch. He didn't send the invitations out until after the party was over. The party was exclusively for time travelers from the future. The result? Absolutely zero guests showed up. Hawking used this brilliant comedic anecdote to point out a simple fact. If backward time travel were ever going to be possible at any point in humanity's future, our current timeline should already be swarming with tourists from the future.
Despite Hawking's empty party, Einstein's equations actually don't completely rule out past travel. But the hurdles, they are monumental. Nobel Prize-winning physicist Kip Thorne theorizes that it requires an unfathomable amount of physics. You would need to generate an immense gravitational field, something like a spinning black hole, just to bend the space-time mesh completely back on itself to create what's called a closed time-like curve. From there, you'd have to find microscopic atomic-sized wormholes in space, somehow expand them to human size, and sustain them using theoretical anti-gravitational negative energy that repels space-time like magnets. Honestly, it's incredibly daunting.
And listen, even if you somehow conquer that insane physics checklist, you still have to conquer the logic. And this builds into the mind-bending grandfather paradox. Just think about it. If you travel to the past and somehow eliminate your great-grandfather, well then naturally you are never born. But wait, if you were never born, how on earth did you exist to travel to the past in the first place? Backward travel basically breaks fundamental logic. The only way physicists can resolve this headache is by relying on the theory of the multiverse, where altering the past just splinters reality into a brand new alternate universe, leaving your original timeline perfectly intact.
So the crucial point here is that while journeying into the future is a tested, proven scientific reality, traveling into the past remains completely trapped in paradoxes and staggering theoretical physics. Which brings us right full circle to Andrew Carlson. Remember our guy who supposedly jumped from 250 years in the future to make $350 million? Well, prepare to have your mind blown. The entire story was a fabricated hoax. It was originally printed in a satirical newspaper called the Weekly World News. Other media outlets mistakenly picked it up, reported it as fact, and the legend of the Wall Street time traveler was basically born out of thin air.
But as we wrap up this explainer, I want to leave you pondering one last, truly mind-bending concept, the predestination paradox. This theory suggests that destiny is completely fixed. What that means is, let's say your friend has an accident and you use a time machine to travel back and stop it. Well, it turns out that your very act of traveling back in time is what accidentally caused the accident in the first place. Everything you do in the past was already baked into your present reality. So, looking at the science, the crazy paradoxes, and the sheer weirdness of Einstein's reality, I leave you with this final thought. If you had the power to manipulate the river of time, which timeline would you dare to visit? Thanks so much for learning with me today.